Bismillahirrahmanirrahim. In our today's lecture, we will discuss about the numericals of chapter number 2. Numerical number 2.4. A body of mass m at rest explodes into three pieces, two of which of mass m by 4 each are thrown off in perpendicular direction. It must be noted that the body is at rest, so the initial momentum is equal to 0 and the body is exploded into three pieces. So let's say these three pieces are these. The mass of first piece is m by 4 and the mass of second piece is m by 4, but mass of third piece is unknown. So m1 is equal to m by 4 and m2 is equal to m by 4 that are moving with velocity of 3 meter per second and 4 meter per second respectively. Find the velocity of third piece. We have to find the velocity of third piece, means v3 is equal to question mark. m1 and m2 are given, but m3 is still unknown and v3 is to be found. So first we find m3. As we know that m1 and m2 are given, so m3 can be calculated by total mass minus sum of the masses of two pieces that are already given. So m3 is equal to m minus sum of masses of two pieces. So it becomes equal to m3 is equal to m by 2. Now we find the momentum of the two pieces whose masses are given. So P1 is equal to m1 v1. m1 की जगह m1 की वैल्यू पुट कर दी and v1 की जगह v2 की वैल्यू पुट कर दी. So P1 is equal to 3m over 4. Similarly, P2 is equal to m2 over v2, which is equal to m. Also, for momentum of third piece, P3 is equal to this, as V3 is to be determined and since first and second piece are moved in perpendicular direction, so P is equal to square root P1 square plus P2 square. By putting the values of P1 and P2, it becomes equal to this, and after simplification, the net momentum of the two pieces whose masses are given can be computed, which is equals to 9m square plus 16m square divided by 16, and P square is equal to square root 25m square divided by 16, which is equal to 5m over 4. This is the net momentum of both the pieces whose masses are given. Now, according to law of conservation of momentum, the momentum of third piece must be equal and opposite to this momentum, because the initial momentum equals to 0, so the final momentum must be equal to 0. To make the final momentum equals to 0, the momentum of third piece must be equal to the net momentum of first and second piece. So P3 is equal to 5m over 4, but with negative sign. Here we ignore the negative sign and take the magnitude only to find V3. By putting the value of P3 in this and cutting the similar term on both sides, it becomes equal to 2.5. So V3 is equal to 2.5 meter per second. Numerical number 2.5. A cricket ball is hit at the angle of 45 degree with velocity of 20 meter per second. The given data is theta equals to 45 degree and initial velocity equals to 20 meter per second. We have to find the time of flight T is equal to question mark. Maximum height is equal to question mark, and how far it hits the ground means range equals to question mark. As we know that T equals to 2vi sine theta divided by g. By putting the values of initial velocity and angle, we have this. After solving, it becomes equal to T is equal to 2.88 seconds, which is approximately equal to 2.9 seconds. Now we find maximum height by using h is equal to vi square sine square theta divided by 2g. By putting the values of initial velocity and angle theta, which is given, it becomes equal to 10.2 meter. So the height is 10.2 meter. Now the third one is the range of projectile, which can be calculated as r is equal to vi square sine 2 theta divided by g. By putting the values of initial velocity and theta, and after simplification, it becomes equals to 400 into sine 90. Sine 90 equals to 1. So it is equal to r is equal to 40.8 meter, which is approximately equal to 41 meter. So the range of projectile is 41 meter. Numerical number 2.6. A 20-gram ball hits the wall of a squash court with a constant force of 50 Newton. Mass of the ball is 20 gram and force is 50 Newton. If the time of impact is 0.50 second, impact time is 0.50 second, find the impulse I is equal to question mark. As we know that impulse equals to the product of force and time, so by using the formula and putting the values, I equals to 25 Newton second.